Coordinate systems. In basic math, we mostly use the one-dimensional number line with the x-axis. In physics, we also use the one-dimensional y-axis. In two-dimension, we are familiar with the Cartesian coordinate system. It uses both x and y axis and it has the origin O. This system can be rotated as long as the angle between x and y is 90 degrees. But let's just use this basic coordinate system. In three-dimension, it makes use of three axes, the x, y, and z axis. The labeling can be changed. It depends on you. And it can be rotated also. But let's just go back to basics. Makes your life easier. Now let's have a one-dimensional motion, a moving car. Let's follow its trail from the beginning. The car is positioned first at x1 equals 0 kilometers at time 1. Then it moves. The position of the car at time 2 is at x2 equals 10 kilometers. The axis used is the positive x-axis. Let's have another example, a falling fruit. We will use the y-axis to describe the motion of the falling object. The initial or starting position of the fruit is at y1 equals 10 meters. When it reached the ground, the final position of the fruit is at y2 equals 0 meters at time 2. Again, the axis used is the y-axis. Now let's have this illustration for two-dimension. At time 1, a boat is northeast of an island. At time 2, its position has changed. Let's take a look in a Cartesian coordinate. Let position 1 be r1. Then it traveled a displacement d to reach its position 2, or r2. The motion of the boat is described by the Cartesian coordinate. The three-dimension. Let's have this cannonball shooting on the air. Using the xyz plane, we can obtain the position of the ball. In three-dimension, the xyz plane makes use of the x, y, and z axis.